So welcome back. This is 7.1, solving systems of two equations, and literally this is essentially just a recap of algebra. We learned about it for a whole chapter in algebra. We're going to just go through it at pretty lightning speed. There are three different ways. If you have two equations, say 5x minus 2y equals 8 and 2x minus 3y equals 1, there are three different ways you can solve this kind of problem to figure out what point intersects both lines, or what point is a solution to both lines. Now we know there's three ways to do it. One is, as we know, is numeric. There's a graphical way, and there's actually two algebraic ways. So I guess in some ways it makes four different methods. But we're gonna walk through each different method using examples because hopefully this will come back to memory what we've been doing back in algebra. So start with the graphical method. This is question number 1 in section 7.1. Is this to solve determine whether the ordered pair is a solution of the system. So this is the numeric way of solving this. This is numeric. And we're trying to figure out, okay, do these ordered pairs 0, 4, 2, 1, and -2, -9 solve the equation? And literally all we're doing is we're just plugging in these points and seeing if they work for both equations. So let's go ahead and plug in 0, 4. We get 5 times 0 minus 2 times 4 equals 8. Which gives us -8 equals 8, so that is not correct. We already realized that this is not a solution. We can just say no. Say no. Let's try the second one. And we have 2, 1. We're trying to figure out if that one's a solution to the equation. So we're going to plug it into both equations, see if it works. So let's plug in 2, 1. So it's 5 times 2 minus 2 times 1 equals 8. We get 10 minus 2 equals 8. We get 8 equals 8. Great. So we know that it's a solution to the first equation. Let's see if it's a solution to the second equation as well, to see if it solves both equations, if it's a solution to the system of two equations. So we'll plug in the same point to 2x minus 3y equals 1. So we get 2 times 2 minus 3 times 1 equals 1. Which gives us 4 minus 3 equals 1, which gives us 1 equals 1. Great, so we know that this is a solution. That's a yes. Finally, we have -2, -9. Let's go ahead and see if that plugs in. In our work, we'll just plug it into the first equation first. So we get 5 times a -2. Let's see, then minus 2 times a -9 equals 8. And so if we plug it in, we get -10 plus 18 equals 8. Well, that equals 8 equals 8. So that's a solution to the first equation. Let's try the second equation. Make sure it fits in both. So you get 2 times a -2 minus 3 times a -9 equals 1. If we plug this in, we get -4 plus 27 equals 1, which gives us, oh, that's 23 equals 1. That is not a solution. Okay, so we know this is not a solution then. So if it has to work with both equations to be a solution to both equations, fair enough. Let's jump to question number 3. Question number 3 says to solve the system by substitution. So we have 3, this is x plus 2y equals 5, and then we have y equals a -2. Okay, so the system of substitution, this is one of the algebraic methods. This is algebraic. And the system of substitution simply just asks us to find a solution for either x or y in one of the equations and plug it into the other equation. So for example, we already have a solution of y here. We have y equals -2. So we can plug that -2 in for y in the first equation. We can plug this -2 into y for the first equation, and then solve for x. So here's what we're going to do. We get x plus 2, and we know that y is -2, so we'll just plug in -2. -2 equals 5, and then we multiply this out. We get x minus 4 equals 5. Put it together, x equals 9. All right. And again, if this was any other equation, this was, if we found out, for example, this is not the case, but if we saw that y equaled x plus 2, the way to put this into the equation, you still plug in the exact same thing. You get x plus 2 times x plus 2 equals 5, and you would work out the solution that way, still figure out what x is, and go from there. Fortunately, we have something really simple, so you don't even have to worry about that. Let's go ahead and solve. If we know that x equals 9, then we can plug that into the first equation, but we have a variable for x, and solve for y. So I could plug in 9 plus 2y equals 5, which gives me 2y equals -4, and then y equals -2. So our full point then would be the point 9, -2, and that would be our answer. Cool? Excellent. This would be the answer. All right, and that's all you have to do it. That's literally all we have to do. Just substitute one, plug it in, and then plug in the other and solve. Cool. So that's number 3. Let's look at number 13. See what number 13 says. Number 13 asks us to solve the system algebraically and support your answer graphically. So it gives us y equals 6x squared, and then 7x plus y equals 3. So this is both algebraic and graphic. Algebraic and graphical. Okay. Let's go ahead and solve first. You can use substitution again to solve for this equation. We know that y equals 6x squared, so we can plug in 6x squared for y in the other equation. So we get 7x plus, well, this would be 6x squared equals 3. Now, honestly, I really don't feel like solving this using any other method than just the quadratic equation. That's just the simplest way to do it. And I'm feeling kind of lazy today, so I'll just use my calculator and figure it out. So we have this equals, this equals 6x squared plus 7x minus 3 equals 0. I just want to solve what that is. Let me pull out the calculator, open up the quadratic solver program, and I get x is 6, a is 6, 7, b is 7, and -3 is c. And that'll give me x1 is 1/3, and x2 is -1.5. Cool. That's really helpful. So we get x equals 1/3 and -1.5. Let's make sure I got that right. Right, -1.5. All right, cool. All right, let's go ahead and find the y's for these. I'm going to use the second equation because that's probably a little bit simpler than having to find square roots. So let's go ahead and plug those in. Let's plug in 1/3 for x. We get 7 times 1/3 plus y equals 3. And then we solve, so that's 7/3 plus y equals 3. Y equals, let's see, that'd be 3 minus 7/3, or that'd be equals 9/3 minus 7/3. So it'd be y equals 2/3. That seems about right. I think that seems pretty clear. Yeah, so one of the points then, plug in 1/3 for x, I get the points 1/3 and then 2/3. Great. The second point is if I plug in -1.5. Let's go ahead and do that. So I plug in 7. Oops, that's not a 7. I plug in 7 times, let's say that's -3 halves, -3/2 plus y equals 3, and then that'll be -21/2 plus y equals 3. That'll be y equals 3 plus 21/2, which gives us y equals 6 halves plus 21/2, and then y equals 27/2. Okay, so then our second point then, if we plug it all in, is -1.5, or 3 halves, and then 27/2. All right, and that is our answer. Let's go ahead and confirm this graphically in order to show this is actually what we're talking about. So if I plug these points in my graphing calculator, plug this in. Let's make sure I'm actually in the right mode. I am in function mode, degrees, cool. So I have y equals 6x squared. This would be 6x squared. And then I have this equation over the second equation. That'll be y equals negative 7x plus 3. I just moved the x to the side quickly in my head. All right, so if we graph that, that gives us this interesting fellow. Let's go ahead and zoom in to see what the intersection points are. And we can say, okay, so we have about negative 1.5, which is, negative 1.5, and somewhere between 10 and 20, which is about what 27 over 2 is. 27 over 2 is like 14. That seems about right. So negative 1.5 and about 14, which is, that seems exactly what's going on here, 14.5. And then on the right side, we have 1/3. That looks like the x coordinate 1/3, and then the y coordinate of 2/3. If I zoom in a little bit more, it looks, yeah, that looks like about 1/3 and 2/3. Seems pretty accurate to me. And so that's just the third way of solving these kinds of equations, just graphing it and seeing where the points of intersection are. That'll tell you exactly what the answers are, because it's the point it's the point that's the solution for both equations, the point that both lines are on. And because as you know, a point that's on any line is a solution to that line, or solution to the equation of that line. So that's why that'll work. Great. Let's go ahead and move on to another problem. Number 19 asks us to find solve the system by elimination, which is, so it gives us x minus y equals 10, and then x plus y equals 6. Now, elimination, this is another algebraic method, so let's call it algebraic 2. Algebraic number 2. Now, elimination is just a fancy form of substitution. I could substitute this out, or I could just remember this elimination method, which just kind of saves me a couple steps of working things out in my head and on paper a little bit, if I want to. And you can think about why this is the case, but for the sake of time, I'm not going to really go deep into this. It's something we learned in algebra. I can add or subtract one equation from another equation and still get a true equation. So I could get 3x plus 7 equals 5, and if I had that equation, and I also wanted to say 2x plus 9 equals 7. If these both equal the same number, well, let's put it more clearly. If 3x equals 9, and if 3x equals 9, and then 4x equals 12, these are both true equations. X equals 3, just in parentheses. X equals 3 over here. If I could put these together and get 7x equals 21. Oh, that also makes sense. If I added this together, 3x plus 4x is 7x, and then 9 plus 12 equals 21, that also makes a true equation. So I can do the same thing over here. If I have x minus y, if I add x minus y and x plus y together, I'll do x plus x, negative y plus y, and 10 plus 6, and that gives me 2x plus a 0 equals 16. Now here's the advantage of elimination. I can eliminate, and the reason why I call it elimination is because I can eliminate a variable. By adding these together, I added a negative y to a positive y, which eliminated that variable. Sometimes it's not as clean cut, like for example up here, it's not as clean cut. You need to move some things around and shift some things around in order to do that. So I'd have to, in this particular equation, number 13, I probably want to subtract both equations from each other. So I'd get 7x plus 0 equals 3 minus 6x or something. If I want to subtract those two equations, or something along those lines. And that's what I would do if I want an elimination route. But here I go, I'll just add these two equations together. I get this. If I want to solve, I get 2x equals 16, x equals 8. Wonderful. I just plug this back into one of the equations and solve. So let's plug it into the second one. So 8 plus y equals 6. I just chose it arbitrarily as which equation to use. We have y equals 8. 6 minus 8 would be negative 2. And we have our answer. So our point is just 8, negative 2. And we're done. All right, moving on to the last problem. The last problem says, or last problem we're working on here today is number 27. Number 27 asks us to use the graph to estimate the solutions of the system. So we have y equals 1 plus 2x minus x squared, and then we have y equals 1 minus x. The advantage of graphing is simply that you can take a really complex equation that you don't want to find and solve for y4 or solve for x4, and you can do it relatively quickly. The disadvantage is it's imprecise. So if I get something like the square root of 2, it's going to be really hard to figure out. If I get like square root of 2 or square root of 2 as my answer, it's going to be really hard to figure out exactly what that x value is, because it's just going to be graphed as a point. I don't really know, or the intersection of 2 points, so it's going to be hard to figure that out. But if I have something in this format, I can just quickly plug in 1 plus 2x, minus x squared. And then I can plug in 1 minus x, and that, plus 1 minus x, and that gives me, let's see if that's correct, that gives me this graph right here. Cool beans. Now, again, we have to make sure we're in the right window. If we can miss one of the points if we're not looking at this carefully. But now, just zooming out a little bit, I can see that there are 2 points of intersection. This first point appears to be at the point what is that? That looks like 0, 1 as one of our points. And that would be correct. So we'd plug in, we'd say one of our points is 0, 1. And we'd say the other points, let's go ahead and go to that other point and zoom out and figure out what that is. This looks like the point 3 something, 3 and then -2. Yeah, 3, -2. Great. Again, these are whole numbers, which makes it super easy. If these ended up being like, say, the square root of 2 and pi, then we'd end up something really difficult to work with. But fortunately, we end up with really whole numbers, which makes our answer super easy, and we're done. That's all we have to do.